All right. Okay. Hey, everybody. My name is Justin, and I am AI for the Masses. And I am back. I've been off for about a week and taking care of some things, but I haven't stopped working on the game, The Story of Someone, my indie game. And I am back to show you what it is that I have been working on. So I did a little studying on making basically maps, dungeons, caves, things like that. Different algorithms for procedurally generated like dungeon content. And I've been like a list of things that I've been trying to wrap my brain around are things like one of the most advanced ones is wave function collapse. So I spent been a few days studying wave function collapse to see how it is that I might be able to utilize it for different map styles. However, if you have been following my devlog process, I have been um, like I pivoted. So I'm going to make an MVP, minimum viable product, and in that version of the story of someone, which it might not be titled that because this MVP version of the game won't be as story heavy. But the idea is that if I can make a game that is fun to play, that is purely a dungeon crawler, then I can take those dungeons and I can use them in my larger scale game. So you can think of it as kind of a prototype, and but hopefully a publishable prototype. So if I can come up with a game that is fun in this much more minimalistic way, then and then integrate it into the much more expansive world that I have been trying to develop, then that game should just be that much more fun. If just one dungeon can be fun, how surely 15 different style dungeons integrated into a story that is built into an expansive world, a big open world, would also be fun, or hopefully way more fun. So, I hey, has anything? How's it going? That was a great stream you had today. So anybody who watches this, check out as anything. So you got your yeah, thanks for the welcome back. Uh, so it looks like you got your website launched, right? I mean, is that what I'm getting from your stream? And if so, then I forgot the website name. You can go ahead and feel free to put it in the chat. As anything is a full stack developer and an avid vibe coder. So he is basically superpowered his skills by vibe coding what he already knows, and he's willing and ready to help people out for anybody who needs that development. And you even had someone in your audience today who looks like they would appreciate your mentorship. So definitely check out As Anything's channel. Yeah, you got in time here. I was just kind of talking about how I think I had mentioned before that I kind of pivoted on my game, not changing the game, but just making a minimum viable product version of my game. And the idea is to make just a dungeon crawler that doesn't have the town, it doesn't have the overworld map. And if I can make that fun and engaging, then having a town associated with a dungeon crawler and then having a world for multiple towns with multiple dungeons and caves and forests and things like that, it should just be that much more fun to have those more expansive versions. So, yeah, no problem for the shout out, of course. And so, uh, what I have been doing for the last week since I really couldn't stream was that I've been doing studying on different map generating algorithms. And I found one that I really liked, and I'll show you guys how it works. So this algorithm is called Cellular Automata, and I like the name. And what it does is, I'll just go ahead and excuse me, I'll just go ahead and run the demo here. That what it does, it starts with, right now I have a binary grid of noise. So this is a 50 by 50 cell grid, and there are just white tiles and brown tiles. Brown tiles represent walls, and white tiles represent floors. Actually, let's see if I can make this a little bit more... I want you to be able to see what I'm doing here, and I think I can change my iterations. Yes, let me go from 4 iterations to 1. So I made myself a little sandbox that can let me test out different, I don't know, I guess different flavors of the cellular automata process. And so if I press spacebar, it will start collapsing based on a simple set of rules into something that looks a little bit like a cave system. And if you can imagine the white being areas that you can walk around and explore, and the brown being the walls of the cave, I'm pressing the spacebar over and over again. That's why you're seeing it kind of erode away. And that's kind of basically how so I think I had to press it like 10 times there. And that's how, at a very high level, this algorithm works. Is that every step there are a set of rules of neighboring cells to each tile. And if there are, I believe, how do I have it set right now? So if I go to the terminal, let's see if we can see the terminal here. Going on the terminal, you can see that I have a birth limit and a death limit. And this is, I think, the birth limit is for the for the wall tiles, and the death limit. So what's going on is, if you have a tile and you look at all of its 8 neighbors, so you know how if you have like a grid, like say your numpad, you've got numbers 1 through 9 set in a 3 by 3 grid, the number 5 is in the middle, and you can look at all the other numbers as their neighbors. If at least 4 of those neighbors is a wall, then you will turn the number 5 key in the middle to a wall tile. If 3 or less are, I have to remember, like this was, I've really had to study this one. I'm already starting to forget some of the rules. And I believe if there are 3 or less, then it'll turn into a floor. So in this terminal, I can change this value. So I can change, let me make sure, oh, am I still in here, or am I'm in a different, oh, I think I got to start a new generation. So let me try again. Oh, that's right. I have to be in this in order for this to work. I don't click on the terminal itself. So I can change the death limit. Let's change it to 2. And then if I press spacebar, or no, if I press a noise limit. So I can also change the density of my noise. So I can have low density noise or very high density noise, and it'll really affect things. So I'll do density of 40%. And then if I press spacebar, it'll start to collapse. But I don't know. You see how it's not quite as... Oh, no, you can't. So if you look, you can see it's not quite as clean in the middle. That's because the death limit being 2 is not really the optimum situation for this particular like application of this algorithm. So I'm going to set the death limit back up to 3. And then I'll set it 40% density again. And now if I collapse, I have more or less like nice empty rooms, okay, and corridors. Now, if I do a density of, let's say, 28%, and I start to collapse, I have like one big open space with like a bunch of little pillars and things that I can work around. If I go to a density of 25, then it's even more sparse. Okay, so this is 25% density. And then let's go up to 28% density. It's a little bit more busy on the inside, just a bit. Okay, and let's go to 32% density. You can see it's still kind of one big chamber. It feels more like one big chamber than it does a bunch of different corridors. But now there are large masses of area that are kind of getting in the way. A lot more to walk around. And if we go to like 36, now it's getting just that much more dense. You can see now there's some dead ends, so some little corridors over here like branching off. And if we go to 40%, which you've seen, then there's more of a hallway kind of effect going on, right? And there are still occasionally rooms that are cut off. I haven't decided yet if I want to connect those or just kind of leave them as is. And I was thinking that if there's a cut off chamber and there's only one tile of wall between the main chamber and that cut off chamber, that I might make this little cell, I think hopefully you can see what I'm pointing at, like a secret wall that will have like a tiny visual clue that you can destroy it. Maybe with a certain type of spell or maybe a bomb, depending on what kinds of items and game mechanics that I ultimately settle on for the game. And then you can blast through this secret room. So if I go up into even higher densities, now we start getting individual, like actual chambers. So I was kind of trying to think, how could I manage this? And perhaps there might be a situation where I could make all the rooms of the dungeon, like maybe I have a cave system that's 5 floors deep, but maybe there are multiple paths to the different levels. So you could find maybe a staircase, the level above this one, for example, that brings you to a staircase in this little node. But then there's another staircase in the level above that'll bring you to this little chamber. And things like that. So trying to figure out exactly how I want to do that. But as I get to like 51% density and even higher, they're not really connected. And rooms get really small and very sparse. You can see I can eat away a lot of them. So I wrote some notes that I don't have them sitting next to me right now, that of what I think was the best. I think 43 is about as high as I should go. 47% density starts kind of making too many individual chambers for my liking. But 43, I have still, mostly well-connected stuff here. So I'm at 43 right now. You can see how there's usually there's like a main space that still survives as one coherent thing. But if I want to maximize the chances of everything being connected, then 40 seems to be about the highest I can go. Now, let's see. Let me find one. I just had one and I deleted. Okay, so like this one here, there's actually a little corner that I would like it for my game mechanic to not allow me to pass through this. But I think that because it's so close, I'll make an algorithm that will know and scan the map and be like, okay, well, let's just open this up a little bit. And it'll like delete one of the wall tiles and connect these two chambers together. So that might be something that I might even try doing today, using like an A-star search algorithm to run through the map and detect if there are disconnected chambers. And what I am thinking I will do is, like, say for this one, for example, there's a chamber here on the top right that is not quite connected to this main chamber in the middle. Then there's like a small one on the bottom right. There's 2 over here on the bottom left, and a medium-sized one like up on the top left. I think I'll have it scan. It'll detect that the biggest chamber is the main chamber, and then it will detect other chambers. And I think I will like measure its, I guess you could say, square meter space, and if it's above a certain size of square meters, but basically square tiles, where our measurement is in tiles, then it will decide to connect. And if it's below a certain tile size, then maybe it'll just leave it be or even delete it. I think it would be safer and cleaner if I deleted rooms that I know I'm going to make impossible to get to. But I still haven't even shown you everything I've done yet. So there's actually a second phase to this map generation. Let me make a slightly bigger room here. So, and now if I press enter, I go into phase 2, which is making pits. So these black squares are representing holes in the ground, like bottomless pits, or maybe a pit you can fall into and you go to the level below. I haven't decided if I want to have that mechanic in there. I know there are some games that I play that do have that mechanic, and I do kind of like that mechanic. However, in the couple games that I know of where that's possible, the character moves one tile at a time, like discreetly, and I have smooth movement. So I don't want to make it where the person would just like accidentally fall off every single ledge they get close to and then end up in a deeper level. That could be a game ending thing. So I think I'm going to make it where you can't fall off a pit unless you basically press a button to jump off. So that way you're having a more deliberate decision of actually falling off. But this is not how the pits settle. So I also use cellular automata for the pits, and I can change the density. So I've locked in this version of the map, but now I can have the pits. So every one of these black tiles represents a hole in the floor now. I can increase the density and then do the automata, and you see how it kind of grows. And now I have large chasm type pits. And if you take time to look at this, it shows like, well, basically this top right area up here is completely cut off. You would have to be able to traverse across this pit. And it's been causing me to think about some other game mechanics of maybe making a float spell or a float potion, or maybe mushrooms that can make you float that you can find in the cave and allow you a chance to get across these chasms. But you also, if you have one to get across, you need to have one to get back. Now you could take a chance and you could find like a floating mushroom or something and go across and hope you find another one on the other side, because maybe it's worth it. Maybe you see there's a treasure chest you really want, or a creature that you really want to fight, or something like that. So you take a chance that it might be a one-way trip. And that also adds the incentive for me to allow you to be able to jump into pits. So you don't want to be stuck in there, but you'd have to fall down to the next level, and maybe you're not ready to fall down to the next level yet, in order to get to to get out of this trapped area. There's even like individual ledges, so I've got like individual tiles that are isolated on another side of a pit. So I can lower the density and just have little holes here and there. And this will help with fighting too. So when you get into a battle, you could be, if you fall down, can you get back up with the mushrooms? In my head, I'm imagining that the mushroom is not like a flying mushroom. It's more of a float. So I don't think you can go back up. Not with the mushroom potion spell that I'm thinking of as float, but maybe there could be some other way to go back up through a pit. These kinds of game mechanics, typically you don't see the pit above you. So it'd be an interesting challenge to make it where if you fall down a pit but you want to go back up, coming back up the pit you intend to, that would be kind of tricky. Now, if my maps were actually overlapping, I have thought about this idea, and because of vibe coding, there really isn't an excuse to not do this extra layer of complexity. What if I generated all the maps for the dungeon as soon as the dungeon is created, and pits can only exist over floors of the dungeon below you? So not only can pits only exist in the floors of the level you're on, but they also can only exist over the floor of the level below as well. So there's a dual layer dependency of where pits are generated. That could be an interesting feature. And then I could add a visual in the art where maybe you can see a glow on the floor. It's like a small glow of light from the level above. If that would even make sense in the world, I guess I would have to make some sort of like little light sources to justify that there's any glow at all. So is there a way to go up? How would you get out if you fall down? Yeah, so I'm going to have to decide if I'm going to, I think I'm going to at least have stairs that go down. Whether or not they're actually stairs or just like a hole in the ground that you happen that is like more specifically you can climb down and up this hole safely, and it's a two-way street. Like a pit, it's kind of like a hole in the ceiling that you can't climb back up, but maybe there is like an area where there's a slope, and in the graphics and in the art I kind of show like, hey, this is an actual path down to the next level, which means you can come back up that path between the levels. I also would possibly consider not allowing you to come back up. That if I'm having this be a dungeon crawler type of game where there's no town on the surface level, that you just start in the dungeon. And there's a game I like playing called Pixel Dungeon on my phone that is like this. You start on the first floor of the dungeon and you can't leave. It's just not part of the gameplay. And so you can go up and down the levels, but what if I just made a version of the game where once you go down, that's it, you're done. You're stuck. Like anything that you didn't find above, like you can't go back and get it. That could be an option. Let's see this. You could have a magical thing that you can find that will teleport you all the way up. I definitely, for the second version of what I think the game will be like, where there will be a town. So I was thinking that first I want to make a pure dungeon crawler, and if that's fun, then I'll make a version of the game where there's one town but multiple dungeons, and there'll be some story around like why the hero is motivated to go into these dungeons, and then it would definitely be much more worth having some sort of a magical type of deal that will that you could get back to the top because maybe you want to go shopping. I'm not sure if I need the magical thing for this dungeon crawler version. It just really depends on what kind of experience I want to give the player. So these are my caverns, and I already have my more grid-like maze type of map, and then there is another map making algorithm I haven't tried yet. I believe it's called binary space partitioning. I also want to do wave function collapse. That's another one. And there's another one that uses, it's really interesting, it like uses a solid body physics way of taking a whole bunch of different shaped rooms, different size rooms, and kind of like putting them all in a big pile and then letting them kind of spread out on their own. And then they're all adjacent to each other and they're all randomly assorted. And then you have an algorithm that'll just cut like hallways between them and doors between them. So you have this very room centric map. There's barely even any corridors between these rooms. It's just one room adjacent to another room adjacent to another room, and that the game works that way. It's also kind of cool because you could probably like lock a special type of room into one location on the map and then have all the other rooms around it, and that kind of thing. So the cellular automata seemed to be the best one for. I've been really interested in making a more organic shaped type of map and dungeon, like a cave or a forest. So I was leaning towards that right now, and I'm trying to imagine what this might look like, so I can reset the whole process. What it might look like to have. I think I gotta. Do I need? Oh no, we're good. Like what would a forest look like? And like this is too sparse for a forest. Again, too sparse. I mean, I feel like this is close to a forest looking path, but I feel like there would be a little bit more maze meandering kind of look to it, not just dense, not big open spaces like this. So I may have to play around with some other technique, or maybe it could be a multi-phase technique. Maybe I do different rounds of that's interesting. You know what? Maybe that's what I do in this stream. So what I just had in my mind that I didn't say out loud is, what if I did this run that you're looking at on the screen right now, and then I added floor noise to all of the wall area and ran another round. I might be able to, if I like take the density really high like this, I can make these little patches. And if I run another one where I add more, like say I lock in these floor tiles where they're not allowed to be changed anymore, and then I run noise onto the brown tiles that are left, I might be able to connect in kind of like a patchwork way a bunch of small cells, and it might end up making a more foresty look. Like say if I did this where there's a lot of narrow corridors and then I ran another round. The trick is figuring out how to do all in this sandbox the same process, or should I just branch out? Maybe I should just make a copy of this code. But I'm trying not to get too distracted here, but that was a good little epiphany that I had of trying to make a forest. I feel like I should stay on the cave until I feel like I've really got it dialed in. So if I do the pits, say on this, increase the density a bit. Yeah, I mean, I definitely like this. It's just I haven't settled on what density values would I want to lock in for the map generator. I think what I want to do is density ranges. So if I can find the highest and lowest density that makes me happy, then I can lock those in, and then I can make a version of this map generator that just does the whole process all at once. So it's looking to me like 40% is a good density. I should make I think I'll do 40%, and I have to do usually at least 9 taps on the space bar. I don't know if you can hear through the microphone that I'm like tap, 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 tap. And I did that so that way you could see the process. But if I go back into my code and I make it where 1 tap is like 10 iterations, so that's why I'm changing the code right here. Then I only have to press spacebar once, and I can kind of settle into what does the map look like if I was to just do that. So we can see here I've got a couple reasonably sized rooms that are kind of broken off. But most of these maps are pretty good. Like, they look to me like they'd be something fun to explore. Okay, so here we've got a chamber on the top right and another one kind of like top left and like center left that are not connected. I have to decide, do I want to connect these or do I want to delete them? I think I want to maximize my space and at the very least make them something interesting out of them, like a game mechanic where if there is a chamber that is disconnected, it becomes like a special room or something that you try to find, like this one here in the middle. It'd be fun to make like one of these 2 walls breakable. So now I'm trying to make the code a bit more how I feel the game would process. So yeah, I really do like 40%. Maybe I could do like 39 or 38, kind of tweak it down a little bit so there's a higher probability of rooms not being separated like this. But like I said, I don't think I mind so much. There's enough. Ooh, wow, this one's an outlier. So this is where these little edge cases here, where it took me like, I don't know, about 15 rounds at 40% to come to this. This would be borderline unacceptable. So this is where I think I would have to make an algorithm that chooses a room to be the main room and then scans for other rooms and then has to decide, is my dungeon big enough? And should I connect my dungeon to other rooms? And I think that's what I want to do. So but I have to make sure that I make my testing interface still work here. So I think what I'm going to do is I'm going to have, let's go to coding view here so you can see what I'm doing. Say now I would like to create an algorithm that helps make sure that rooms that are not connected to what would be considered the main chamber get connected. So I think I have to decide. So I think first, I don't want to do too much scanning. I'm trying to decide if I should just choose a chamber and then just declare that to be the main chamber. And then if it discovers other chambers that aren't connected, then start deciding if it wants to connect them. And then I have to choose a size. So how do I choose the first room? Like, okay, this one's obvious. It's all one thing. All one thing. All one thing. Oh, it's because I'm doing lower than 40%. Like I said, like 36 is pretty good. Like very few outliers. So here's a couple outliers here at 36. So it's not guaranteed. So now I'm gonna raise it to 40. So like all of this main stuff is definitely one main chamber. But what's the best way to detect that there's a main chamber and start? I want to scan the main chamber first. Okay, so here are two large chambers that are technically, based on the rules that I'm going to create, actually three. So two large chambers on the left and the right. And then down here on the bottom right is a smaller chamber that is technically not connected. I'm not going to allow diagonals to be considered a connection. So which one of these two bigger chambers is the main chamber is a question I need to answer. And then how will I get the algorithm to detect this? One thing I'm going to try is, let's see if the AI has an idea based on previous algorithms that exist out there in the internet. Okay, so we're gonna brainstorm with the AI first. This was a good run. So now I'd like to create an algorithm that helps make sure that rooms are not connected to what would be considered the main. Rooms that are not connected. That is I think the AI can understand what I'm trying to say here, but that is a horribly written sentence. Let's see. And now I would like to create an algorithm that makes sure that, let's just say that all rooms are connected. Connected to what would be considered the main chamber. Yeah. Okay. In the image, there are two large chambers and one small chamber. I wonder if I should mark up on this. Let's see. So I think I'll circle in red. One chamber. And then I'll circle in blue the other chamber. And then I'll circle in yellow the small one. Now, wait a second. Hold on. I wanted to see that little corner there. Okay. Okay, I'm going to do that. In fact, I'm going to provide both images. I circled the two large chambers in red and blue. But there is a smaller chamber in the bottom right, circled in yellow. Notice that I do not consider diagonally adjacent. Yeah, that should work. Let me spell this right. Diagonally adjacent floor tiles as connected, as connecting to chambers. Only horizontal and vertically adjacent floor tiles are considered to be a connection. Okay. Can we discuss... Actually, I feel like it responds well to brainstorm. Can we brainstorm a way to decide which chamber is the, and I'm going to put this in quotes, main chamber? And then how would we decide the methodology? I'm going to spell this completely wrong. Oh, did I not? Oh, wow. I do know how to spell methodology. And then how we would decide the methodology to connect the chambers together. One last thing. I am considering not connecting small chambers for, let's see, for purposes of game mechanics. That could be fun to find secret rooms. How could we also avoid, let's see, how could we also like detect those smaller rooms while not actually connecting them? All right. Let's stop there. Let's see what kind of a response we get. That was a lot of explanation there. But I think this, I really like this chamber, this set of caves that got generated is a great example. Yeah, I want to stick with around 40%. So I want to make this thing pretty robust. So I don't mind having like this chamber connection problem. Okay, so excellent question. This is a classic and crucial step in making procedures that generate caves playable and interesting. Oh, as anything, what are some of the UI improvements you've noticed in Gemini? Oh, yeah. One is for sure up here. So let me see if I can find an example It's mostly in how it presents its code now. And I actually ended up getting like Google just popped up a window on me one day and said, "Hey, would you be willing to do a survey about your usage of Gemini?" I was like, "Yeah, sure." And I actually asked for this. So I must not have been the only one, because they updated it exactly what I asked for. So usually when you get this code window, you have to scroll to the bottom in order to copy the code. But now they put the copy button at the top, because I don't usually read all of the code anyway. So not only is the copy button at the top, but now I can collapse that code window. And instead of having to scroll through the whole thing after I've copied and pasted, I've got the next one right here. And then I can press copy, and then I can collapse, and then I can press copy, and then I can collapse. I was like, oh, that's so much better. Like, with the way that I have been using Gemini, this is exactly the UI I have been wishing for. Yeah. So that is the case. I was very happy to see this. Okay, so let's see what the response was. Core problem: identifying disconnected regions. Before we can connect anything, we first need to programmatically identify the separate regions you've circled. Well, they're not going to be circled all the time now, Gemini. Don't get mistaken. The perfect algorithm is flood fill. Okay, not surprised that we're choosing flood fill. Okay, create a copy of the map or a secondary 2D array to keep track of tiles we've already assigned to a room. Iterate through every single tile of your map from top left to bottom right. If you find a floor tile that you haven't visited yet, you've discovered a new distinct room. What? Hold on. Every single tile of your map from top left to bottom right. Okay, I see what it's saying. I feel like it wasn't completely clear, but I see what it's saying. So I think it's going to do a fill in a room, and then it's going to scan the whole map. And if it finds tiles that still haven't been filled, it'll be like, hey, that's a new room. Okay, that makes sense, because it's going to use a flood fill like in Photoshop. And you just go to a new room. Start a flood fill from this tile. The flood fill will fill every single floor tile connected to it, orthogonally, not diagonally, as you specified. Orthogonally. I'll have to remember to use that word. Store all of the tiles belonging to this new room in a list. A good data structure would be, where each inner list represents one room. Oh, okay. Cool. Boy, this is interesting. As the flood fill runs, mark every tile it touches as visited. Continue iterating through the map. Since the flood fill marked all the tiles of the room you just found, the loop won't redetect it. It will only stop again when it hits a floor tile from a different room. After the loop is complete, you'll have a master list containing several smaller lists of points, with each smaller list being one of the disconnected chambers, like your red, blue, and yellow circles. Okay, deciding the main chamber. You need a reliable way to determine which of the found rooms is the most important one. Here are a few common methodologies with a clear winner for each for this use case. By size. Yeah, I agree. The largest chamber. This is the most intuitive and effective. Okay, so it's going to do a flood fill of each chamber first. When it finds a floor tile, it's going to do a flood fill, and then it's going to scan. Am I finding another tile? And then if it does, it'll do a flood fill until it scans the whole map without finding a floor tile. But it will then detect how big each chamber is, and the biggest one will be the main chamber. Okay. The main chamber is simply the room that contains the most tiles after the flood fill step. You would iterate through your list of rooms and find the one with the highest count. This room becomes your main chamber. By position, you could define the main chamber as one of the closest to the center of the map. I don't necessarily need the main chamber to be the closest center of the map. Just the biggest. And I like it that there will be a selected main chamber, because I think I want to put my entrance in that main chamber. So I don't necessarily need where you go down from one chamber to be in the same spot on the map as another chamber. The different levels just might be constantly moving west for all we know. So I think I would just like the stairs to be, maybe it's like in an area that is closest to a corner. I don't even think it matters. I don't think I care if the stairs are in the middle or anything. I've played a bunch of dungeon crawler games where when you just don't know where you are, you'll go any direction, and it really doesn't matter where the stairs are. I think as long as the exit stairs are at least a little bit of ways away, but even then that doesn't matter because you don't necessarily want to just go down to the next level right away, especially if there's a scaling feature to the dungeon. So you wouldn't want to go to the next floor quickly necessarily because the creatures might get harder, and I think I want that kind of element. And plus there's things to find on the map that'll help you out. So I don't think that's a problem either. I think I'll just randomly place my stairs. Okay, so the only thing is that the main chamber, if I'm going to have secret rooms, I want the stairs to be in the main chamber, which should be the biggest chamber, and then small rooms, maybe below a certain threshold, might be secret rooms that you have to find. So that is a good reason to have a main chamber chosen. Okay, so let's go here. So connecting the chambers, this is the most interesting part. Oh, it says, okay, well, I'm excited. Once you have your main chamber and a list of other chambers, how do you connect them? Methodology: find closest points, then tunnel. Find the closest points for every other chamber. You need to find 2 points, one in the other chamber and one in the main chamber that are closest to each other. This can be a brute force search. I hope these searches don't take too long. They shouldn't. These are not huge maps. I think I wouldn't want my map to be much bigger than what I've already created. This is a 50 by 50. Based on how things look to me, I kind of like it. I might go as high as a 60 or a 70, but probably not much higher. And then I was even thinking about making different floors be different sizes. So I could have a 30 by 30 and a 40 by 40, or even long maps. I haven't even tried changing the dimensions to a non-squared shape. So that way, like, the player it's just so much more unpredictable. The player can't have any particular expectations. Every single time they play, it's just going to be a different vibe. I think it would be really neat if I made one dungeon or cave system that's all really long, narrow caves, long, narrow floors, and you're constantly just going east and west, or just north and south. Like, I can create a lot of different feelings to these caves, or maybe I make a sewage system where you really are, you're going deeper and deeper, but it's always moving downstream. So, yeah, that's what I like about all this procedurally generated stuff. Let's see, so here we go. So looks like we got some pseudocode here. For each tile A in other chamber, for each tile B in other chamber, or in main chamber, calculate distance between tile A and B. Oh, if this distance is the smallest so far, save tile A and tile B. Okay, wow. Oof. Boy, that's brute force. Starting with one tile in one room and checking its distance to every other tile in the other room, and then doing another tile. Is that seriously? There's got to be a more efficient way than that. Okay. Well, we'll see how well this works. I definitely don't want to visualize every part of that step. I think what I'll have it do is do that behind the scenes really quickly, but show the answer. And then I'll verify if the answer actually makes sense. Are these 2 tiles the closest 2 tiles? And like highlight the 2 closest tiles, and then I can press a button to do the carving step. So, carve the tunnel. Now that you have a start point and an end point, you need to carve a path between them. The best algorithm for drawing a line on a grid is a Bressenham line algorithm. Okay, I think this is the first time I've come across this word. There was another algorithm that I had come across I'd never heard of before. I don't think this was it, so I think this is new to me. You would run this algorithm between the 2 closest points you found. For every point XY that the algorithm gives you, you change that tile in your map to tile type.floor enhance. A one tile width tunnel enhancement. A one tile width tunnel can look a bit thin and artificial. To make it look more natural, you can make the tunnel thicker. I wonder if I could just like run the algorithm. Cellular automata. I had to, boy, I really brain farted on that one for a second. What if I just run the algorithm another couple iterations to expand the path? That would be an interesting. I think it would work that way. Yeah, I don't necessarily want to carve out a 2x2 or 3x2 3 area around it, but it's probably good enough for this purpose. We'll let it do that method first, and then maybe I'll ask it to do the automata instead and see how they compare. The old Bressenham algorithm. I don't know it. Right. Wait, aren't you like, you're all full stack. You should know all these algorithms. By the way, as anything, you're not a computer science major, right? Like officially, like you like like taught, right? Oh, what? What are you shushing me? Hopefully, I don't know if you're responding to my question or if the lag was long enough that you're you're responding to something else. But I feel like someone who took like a full bachelor's in computer science probably had to like be exposed to like all these algorithms, and they probably use like 5% of all the algorithms they ever okay, yeah. So I did choose the ultra low latency on this stream, so it looks like there's a much lower lag. So I'm getting your responses near real time. That's a lot of fun. I'm glad. Usually it's like a good 15-second delay. Just joking about the No, I have a degree in biology and I self-taught programming. Yeah, cool. Well, good job with the biology degree. Yeah. Well, you should know cellular automata, right? That sounds very biology. So yeah, Bressenham algorithm. I don't even know if I'm pronouncing that right. Okay, so handling the secret rooms. Okay, fantastic design ideas, very easy. Okay, well, define a threshold. In your map config.cs, you would add a new parameter, something like secret room tile threshold. Let's say you set it at 15. I think I'll probably set it a little higher than that, but yeah. I just kind of took a second to like look at that room that's still in my run on the screen here, and that looks like that's at least like 60, 70 tiles or something like that. So, and I would even consider that one to be a potential secret room. After you've identified all the rooms and found the main chamber, you modify the connection logic. Create a list of rooms to connect. Iterate through all your other chambers. If a chamber's tile count is greater than the secret room tile, add it to the rooms to connect list. If its tile count is less than or equal to the threshold, you simply do nothing with it. It remains a secret room disconnected from the main cave system. Okay, I'm going to add a layer to that, but I'm not going to talk about it with the AI right now. First, we're going to connect rooms we want to connect, and then we'll just not connect rooms we don't want to connect, and then I'll ask it to create the secret room system. Gives you a simple configurable way to control how large a room needs to be before the game considers it important enough to connect to the main path. Putting all together, the file algorithm flow. Okay, good. Do that. I'm tempted to just say do that, and I think I can. Yeah, I think I'm going to say this plan looks good. Let's write the code for this plan. Okay, let's go. So as what's up with the biology degree? Do you do anything professionally with that degree? If you're, while you're potentially answering that, there was a topic that I was thinking about having today, and I'm trying to remember what it was. Oh, okay. I know what my topic of the day is. When As Anything streams, he likes to have a topic of the day. There was a topic that came up on the day of GPT-5's release that I thought was very interesting, and it was the idea that if we can simulate worlds with AI to the point where it feels like it's almost an entire universe that might temporarily exist, who's to say that we aren't in a simulation as well? And that's not really what the topic is about. It's just the premise. A lot of people who are into AI already have had this particular part of the discussion many times. Are we in a simulation? Maybe that's what these AIs are, just simulated worlds. And as we get more advanced, we're basically making whole other worlds. Okay, so is it possible that we are in a simulation? Is a question that gets asked a lot these days. Now, AI has gotten smarter than any individual human in a lot of very specific tasks. Playing chess, Jeopardy, the game Go, doing folding proteins, writing research papers, gathering research, all kinds of stuff, right? Just writing in general, making images. So if the AI is smarter than us, and we humans, a collection of us, but we humans are the ones that made the AI, then if we could simulate worlds in our AIs, wouldn't that mean that if we are living in a simulation, that the entity or whatever that created our simulation is dumber than us? Just let that simmer for a minute. All right. So here we go. The changes will affect all 3 of our core files. Yes. Oh, I love this new format. I hope that if I start a new chat, that it keeps doing this. Here's your first file, and it's changed, and then it just gives me the file, and then all I have to do is just go copy. I'm just like giddy. I'm like a little kid right now. Like, this is so much better. And then I just do that, and then I collapse. And then the next one is map generator, and it is changed. So then I just go here, and I go copy, paste, save, and then I collapse. And then program, okay, and it has been changed also. And then I just collapse, and I go to program.cs, and boom. And see, it has some little artifacts. Shame on you. Okay, those are the only 3 things. Oh boy. Okay, and I'm done. I mean, I didn't have to do a whole bunch of scrolling and As Anything. It's an interesting idea, but I don't think AI is smarter than us. AI is only smarter than us in the same way that a calculator is smarter than us. Agreed. Your point is extremely valid. I guess my follow-up question then would be, do you think that AI could be smarter than us eventually? I mean, I feel like that is basically the definition of AGI, although we have not standardized our definition as humanity has not standardized our definition of what AGI actually is. And I feel like I'm going to go ahead and kind of throw this one into the conversation, that even if the AI was capable of doing everything better than what we can do, everything we can imagine, like we put AIs into robots and they're able to sort things and move stuff and paint better than us, like paint an actual wall or create a building and do things like that, all like physical labor as well. Just because it can do something better, just like you were kind of saying, does that necessarily mean it's smarter? And would smarter than us require sentience by definition? That I am not an AI expert, but I don't think we can call any version of large language models smart any more than you can call any algorithm smart. I don't think I fully agree with that last statement. But I think I know what you're talking about. And I'm not saying I disagree with what you're saying. And I feel like the times where I come across what I feel is kind of like not quite being in agreement with someone else on these AI topics, like when people say, well, these thinking models of AI like GPT-03 and stuff that are thinking, they're not actually thinking. My response has usually been, it's like, well, then what is it doing? Because it sure seems like it's thinking. So maybe we need to use a different word. And so I can agree with you that you can't necessarily call large language models smart, but maybe it's because smart isn't the word we should be using. I think we could maybe swap out the word smart for adaptive. Okay. I could see that. I will support your statement about not smart in that I don't think we have quite crossed the threshold. We kind-ish have, but I don't think we've quite crossed the threshold of AIs and large language models especially being able to truly problem solve. They can come up with answers to already understood questions, but with extremely limited exceptions so far. They're not able to answer unanswered questions. And I think that would be the threshold, the beginning of the threshold of having a strong argument for calling even a large language model that can do that smart. All right. Oh, okay. Let's run this. Let's see what happens. I don't even know how I'm supposed to control this code. So does it do the pathfinding in the form fill once I press enter? I need to does it have instructions in here? Okay, well this one doesn't have any separated rooms, so let me intentionally. Okay, that is a lot of separated rooms. So now what? Enter? No. Enter again? Yeah, I don't even know how to use the code it gave me. Describe for me how to run the program so that I may test the chamber connection algorithm. All right. And that is the downside to vibe coding blindly is, okay, you did something. How do I use it? Usually it was giving me a description of like press this button. Oh wait, maybe it's in my terminal. Reset land phase exit pit noise run 4 pits. Select pit rule to modify. So change pit rule for. Yeah, I'm not seeing. Oh, reset land. Yeah, no. Okay. Oh. Okay, here we go. My thinking is that they're not even playing the same game as intelligence, so we can't cross the threshold because they're doing computations to match requirements rather than evolving independently. Interesting. So, do you imagine that AIs might be getting close to that at any time in the near future? Have you seen any evidence, or have you been like how much? I don't know how much you watch AI news because it's like constantly coming at us all the time. Do you think that there's a possibility that that requirement that you're suggesting might be able to happen soon? Of course, here's a clear guide. Okay, so no, that's just okay. You're going a little too far back here. I know how to start the program. Um, Several white islands or caves. Okay, run the connection island. With your disconnected cave system visible in the window, press the C key. Haha, okay. All right, can I do that now? No, I have to be back. Okay, so let's do this. Add some more density. Yeah, okay. C? Whoa. Okay, kind of fat corridors. I don't know if I like that. But definitely, I don't hate it. Interesting. That's weird. Oh, interesting. I can connect even with the noise and then collapse. That's cool. Wait a second. Hold on. Interesting. Changing the order. Wow. I don't hate that. I find that to be rather fascinating. It makes some very interestingly shaped caves. Oh, that's neat. My guess is no. I don't think AI is doing basic thinking that could improve, but rather it's doing incredibly advanced guessing that can't improve any further. So I forget. I think it's Alpha Evolve, and I think we talked about this before. I haven't seen any new updates to Google's Alpha Evolve, but apparently it does modify itself. And that is how it discovered some new mathematics, and like quite a few examples of new mathematics. I forget what the name of the algorithm was. That it's like a solution to an incised matrix of complex mathematics, and it takes 49 steps, and it was like something that we solved. Any set of complex matrix math can be solved in those 49 steps, and Alpha Evolve figured out how to do it in 48. And we haven't had an update in that algorithm for like 60 years, and Alpha Evolve did it. So I kind of feel like that's an example that is trespassing into your requirement, but we'd have to look deeper into the details of that accomplishment, and I would need to understand your requirement better to make the argument that qualifies. You can do that by guessing or estimating, though. I think I might have gotten a little lost. Let me read. Okay, my guess is no, I don't think AI is doing basic thinking that could improve, but rather it's doing incredibly advanced guessing that can't improve any further. You can do that by guessing or estimating, though. Okay, yeah. I mean, definitely estimations or even tests. There are algorithms out there, like say doing using a Taylor series to find the approximation of the square root of 3. There's no actual exact answer to the square root of 3. It's an approximation, and in some ways you find the answer by starting with a guess, and then you collapse it down to get closer and closer and closer to have a more accurate approximation, but there is no actual exact answer. The last message response to you, the Alpha Evolve comment discovering new content. Yeah, I'm not used to you being able to respond to me so quickly to what I'm saying. So you can do that by guessing or estimating. You know what? I am not convinced. Again, I don't understand what Alpha Evolve did well enough to make a nuanced intellectual argument for what I am hypothesizing. But I feel like if you and I were to take the time to really dig into that and what Alpha Evolve claims to have accomplished, I think we could come to an agreement on whether or not it is at least starting to meet your requirement. I think that'd be an interesting thing to learn more about. But we're both so busy. I don't have time to be speculating on something that'll probably be answered in the next year for us anyway. we're gonna know. So much is going on, but it is fun to talk about for sure. Yeah. Okay. Man, do I like the fact that this is working, and then I can add the pits. Oh, this is so good. I'm pretty happy with what's going on here. I'm scared about the pits and making the game unplayable. But now that there's this whole main chamber concept, it would be kind of neat to do like a fill or an A-star algorithm to create some ways to detect a main chamber after the pits have been established, and then placing resources to make sure that you can get across the pits. I am also, is it for sure, it's good to talk about, but I'm no expert. I am also definitely not an expert. I like to feel like I know a lot, but boy, when you learn more and more things, you just start realizing how much more you don't know than you know. So yeah, yeah, I am far from being an expert as well. I do feel like the people who are literally being given $100 million bonuses are making me feel like I picked the wrong engineering. It's like, oops, should have gone into AI. All right, man, how long have I been streaming? Probably could. I don't even remember where the clock is. Oh, okay. Been a little more than an hour. I feel like I've accomplished a small but important accomplishment. And I've been on here for a little over an hour. And don't want to burn myself out. Let's kind of warm up to this again. It's been a while since I streamed. I'm happy with this. This was good, and boy, do I, like I said, I really like Gemini's update. It's very satisfying. I mean, just seeing that how quickly I was able to add all that code in. Yeah, I think that will do it for today. If I keep it small, manageable sessions like this, then I think I can mentally handle a bit more consistency. So I think I'm gonna call it here, and I'll commit this update because that was a good update. That is a powerful little algorithm that added. I think I don't want it to connect so broadly. Those are pretty fat connections. And let me just do it one more time just to demonstrate what I'm talking about. So, like if I do I think I'll get a connection down here, maybe on the bottom left. Yeah, and they're just huge. So I should, in program.cs, I want it to make me a JSON file that has all the stats. So yeah, where is it doing the connection? Okay, before I go, I'm going to say add the connection width as a config setting to program.cs. I don't think I see it here. So I don't know where that is happening. So probably in map generator, there's going to be like a connection. Could be carve square. Create tunnel. Here we go. So somewhere, here we go. Carve a 2-tile radius square to make tunnels thicker. It's only 2? It feels so big. I feel like, oh, radius. Yeah, see, there's the problem. So I think I would like it to be a 1-tile radius. I could just change it right here, but I think I would like it to be a value that I can adapt, and also potentially have the code maybe even make a range of 1, 2, and 3 for different styles of rooms. So once again, here we go. So replace the constants in map config. I don't even have to look at it if I don't want to. And then collapse, and then map generator. Yep. And then collapse. And I got a bunch of errors. Okay, that's because I didn't. Whoa, why is this so big? Hold on. That is a huge file. Are we sure about this? Or did I click on the right one? Wow. I knew it. Okay. A little bit of a bug there for Gemini. So it combined 2 codes. Not a problem. I will snip out program.cs. Yeah, right here. And paste it in here. Okay, and then clean up the bottom here. So that is one trade-off to this new super efficient and somewhat complacent update or way of using Gemini. Is usually I'm able to kind of scroll through and see if like a little quirk like that happens, and now I don't have to scroll through anymore, so I could end up missing when that happens. All right, let's see. Well, first I wanna go see the update. All right, so now we have tunnel radius 1. Okay. Now if I press connect, yes, those just look a little bit cleaner to me. I like that. Okay, let me do again. Let's do much more disconnected. Still feels kind of thick. 3 by 3 total width. Can I just do tunnel radius 0? This is why I think I would like to do a tunnel radius of 0 and then do another cellular automata collapse, because I think I can kind of organically grow the wall. So let me just do this one more time. Okay, yeah. Hey, I'll see you later. Thanks for joining, and congrats on your stream. Boy, it'd be fun to see how your Discord grows. I definitely want to keep an eye on that. And the new guy that joined your stream, I'd like to see if you guys are willing to have your discussions publicly on the Discord. I'll definitely be tuning into that as well. So thanks for joining. I always appreciate it. I'll see you around. All right, let me collapse. Let me do the connection. Okay, I definitely like this. Let's try again. Still fat. Wait, hold up. Did I actually update? I didn't press save. Silly. All right, let's try this one more time. Okay, and then connect. Ah, yeah. See, that doesn't quite work. The 3 is so big. All right, that's fine. I'm not going to be too picky about it right now. And when you're like, I bet you if, thanks. I'm excited to see it grow. My goal is to share a lot of public educational material around vibe coding on stream and in the Discord, not just from me, but from the whole community. Yeah, that's why I was like kind of asking him. Unfortunately, I I started driving when he responded when I was asking him like, "What AI do you use?" And then he didn't know what an IDE was, which fine, if you're just starting out, why you don't necessarily know. Well, you definitely don't know everything for sure. So unfortunately, I didn't get a chance to respond to him, but that would be like what the community would be for. So yeah, I'm excited as well. This should be a lot of fun, and this is all cutting edge stuff, right? No one is an expert on this, on how to best do these things. Everyone is figuring this out right now, so let's be a part of it. Yeah, exactly. Just talking about the terminology is very valuable. I agree. And then as new tools that didn't exist in the past start growing around all this vibe coding, we can all learn together. Yep, I'll catch you next time. Thanks for joining. Let's see if I can try it now. Oh, I'm going to blindly create a map and see how I feel. Yeah, not exactly the kind of... I'm like closing my eyes, connecting the rooms and seeing if I can see the paths. I don't really like it that they connect in such straight lines. I wonder if we can add kind of a meander between the 2 points. Let's do that. Can we create a meandering effect to the path, or what is it, the chamber connection? How do they label this in the code? I want to use the same. Oh, a meandering effect to the tunneling process. I do not like the straight line look. It slightly ruins the natural feel of the cave structure. Okay, yeah, let's see how this goes. I am gonna commit what I have right now, though. I do at least like what's going on. So while it's doing that, I'm gonna go ahead and commit, try this out, and then I will end the stream for the day. So added a chamber connection algorithm to the map making process. Okay, what do we got? Fantastic idea. Best way to achieve this is replace our precise Bressingham line algorithm with a more chaotic but guided method. A guided drunkard's walk. Oh, wow. It works by taking mostly random steps, but biases the randomness to move generally toward a target. Yeah, okay. I definitely am curious how this is going to look. I have a feeling I'm going to like this. Uh-oh, what's going on? Something's a little off here. What's happening? Huh. It's like it didn't copy the whole thing. Or did I copy the wrong? Let's see here. Did I have to go back and watch? Did I even prep? Hold on. All right. Got a little interrupted there, but it's okay. Let's see what happens. Looks like that's... Okay, and now connect. Ooh, I think I see what happened there. Okay, let's try this. Okay. Interesting. It still feels kind of straight to me. I think I would like, instead of there being a radius, for the path to just be 2 tiles wide. Or maybe it could be like, it could fluctuate between 2 and 3 tiles. Like every iteration as it's moving through is like 2, 3, 3, 3, 3, 2. But maybe that's an update for a later time. Let's see. I'll make this really sparse. Still, I mean, it looks pretty good. It's definitely got corridors and stuff like that. I feel like it's a useful... Yeah. I'm pretty satisfied. I like this one better. This one feels less just straight lines that I can like really see. This feels a little bit more like I'm just creating kind of like this network. All right. I am pretty pleased with this. I think I'm going to end it here. Okay, well, yeah. So my name is Justin. This is AI for the Masses, and I am making my game The Story of Someone. If you like what I'm doing, as all YouTubers say, please like and subscribe and follow me. I will be working on this for months, if not years, and as this gets further and further along and AI gets better, I hope we can all learn together the different techniques that we can use to make fun and interesting apps, games, entertainment, and just make this world a more fun place to be. All right, I will see